Today's video is sponsored by 6 Foot Tall Tumbleweed. Listen to the new album Wheel of Suffering on iTunes or on Spotify today.
Dark skin, bright eyes, big booty, and thick ass thighs.
Hello beautiful people, Brad the Guitologist here. In this video we're going to take a look at this amplifier. This thing is supposed to be somewhat rare. I believe they only made it for 1 year or 2 years at the most. This is a 1992 or 93 Fender concert amp. And let me see here actually on the schematic. It does say 93 Super and Concert. So I guess this schematic is for both of those models. This one supposedly has something wrong with the reverb, I do believe. We're going to see what's going on with it. I'll plug it in here and we'll test it out. See if there is indeed a problem with the reverb, and we'll troubleshoot it from there. If that sounds like something you'd be interested in, please stick around. Yeah, like I said, this 93 concert amp is fairly rare, so let's get a look at it while we have it here. Here are the controls. We can see concert amp here. We have a reverb and a mix control over here. We have 2 channels basically with 2 inputs. The first channel over here has a volume, a treble, bass, and mid, and this volume allows you to cut when you pull. It says pull for cut, and I'm not sure what that's supposed to cut. Maybe treble, I'm not sure. But it cuts something. Here on the second channel we have 2 different gain controls. We have gain 1 and gain 2. This gain 1 control says pull channel select, so if we pull this it will select the second channel. If we pull this one it will select a different gain structure. I'm presuming it probably goes through some ICs or something like that perhaps. We have a treble, bass, mid, and then we have what I presume is a channel volume or master volume for this channel. Not sure what the mix control does. So it turns out the mix control mixes the wet signal from the return of the effects loop with the dry signal of the rest of the amplifier. This is, like I said, this is an odd amp. They only made it for like 1 year or 2 years at the most. So let's spin this thing around. I think the customer left me a note. I'll read the note here and see what the real complaint was with this. Okay, here we go with the rear of this thing. You can see it has the original Fender musical instrument labeled speaker, and it is a 12-inch speaker. It's manufactured by Eminence, right here in good old Kentucky. It was made about 20 minutes from my house. As a matter of fact, one of these days I need to take a trip over to Eminence and take you guys along, and we'll do a factory tour of the Eminence factory. I need to call them and see if that's okay with them. I'm sure it would be, but they do give factory tours, I think, from time to time. That would be a cool video. Over here we can see a chart. Let's see, Fender Musical Instruments, Brea, California. Get a good look at the tube complement here. Also on the other side of the cabinet over here is another tag. Kind of surprised actually. It looks like the whole thing is made from plywood, even the baffle. I can just make out some wood grain there on the baffle, so it looks like even the baffle is actual plywood, so that's interesting. This thing came with the manual, and again this is the manual for the Super and the Concert, which were the exact same amplifiers apparently, with different speaker configurations I presume. We have, again, a letter to me, I guess detailing what all was wrong with it, and we have the original foot switch. Now this is a 3-button foot switch. It selects reverb, it'll select the gain on that second channel, and it'll select the channels themselves. On the rear of the chassis we have a foot switch plug, an effects send and return, and that can be attenuated there down to -24, -11, and +2 decibels. Here is a line out, external speaker jack, internal speaker jack. Here we see some more information. This is a PR244, so that will be the actual part number for this thing. And we have our on, off, and standby switch, and our fuse holder over here. Okay, let's take a look at the letter that was sent with this. It says, essentially, he's had a reverb issue with this amp for years. It's been worked on a couple times, but he never really got it fixed properly. The reverb cuts out, but he can usually get it working again by fiddling with the RCA connectors on the head. Okay, so yeah, and he's saying, you know, there's probably some kind of bad solder connection, something like that, and I would concur with that. That's very likely the case. He says the reverb sounds really nice when it's working, and also sometimes he hears a crackle here and there, and it might be a tube socket cleaning issue. So yeah, let's go ahead and fire this thing up, listen to see what it's doing, and we'll go from there. Okay, let's fire this thing up on the Variac. Okay, at 120 volts on the primary, we are at 0.82 amps of current draw. We are at 82 watts of power, and that'll probably go up just a little bit as it continues to warm up. No reverb. That's the speaker jack that's dirty. So we'll have to clean that. That speaker jack's definitely dirty. That means other jacks are probably dirty as well. Let's see what's going on here. Okay. Yep. Yeah, there's definitely bad connection or something going on with that reverb. Let's go ahead and pull the chassis. I can already tell we're gonna have to do that anyway to try to kind of get to some of these tubes. They're a little less accessible on these more modern Fenders than they were on the older ones. So let's go ahead and pull the chassis and get a closer look. Yeah, I can already tell before even getting this chassis out of here that these leads for the reverb have probably been changed. You can see there someone has repurposed like an audio video pair of cables for this purpose. They're very nice cables, thick, probably really nice gold plated tips, but you can tell that they're just, you know, they really don't look the part. They're probably not factory, but still they should be good cables, and I don't suspect them of being the problem. I think what happened is whoever put them in probably pressed them in too hard. You can actually see when I wiggle this one, especially it's this one over here, there's just a lot of play in this. Well, look at this shit fest, man. This I don't think I've ever seen anything like it. You can't get to anything in this amp. You literally cannot get to anything because the boards cover the entire bottom. I mean, look at this. All of the sockets are direct mounted to the board, for one. So there are all the sockets. So in order to remove this board to access anything underneath, I'm going to have to remove, it looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 screws, 11 screws, 12 screws, excuse me, on this top board. The controls have their own board that's separated. But every single socket, every single tube socket has a direct mount. Is that the reverb connector right there? That is the reverb connector right there. I think before I take this whole board out to try to access this reverb connector a little better, because I think I'm still going to have to take this out to access this reverb connector. That's the connector right there. I think what I'm going to try to do here is see if it's possibly a loose connector on the cable first. Alright, I got the cabinet back up here on the bench with this thing. It's probably going to be about the easiest way to do it. Before I do anything, I'm going to spray these connectors just to make sure that they aren't the source of the problem. I'm also going to, I don't know if you can see it, but the ground connection on these is segmented. You can see here there's 4 little segments that make up the ground connection, and I'm going to spray this and clean it, but I'm also going to gently squeeze in this ground connection, especially on this one, because this is the one that was seemed to get a weak connection. Okay, so I'm basically just going to squeeze this in very gently to try to get a better ground connection. I'm also going to go ahead and clean this speaker connection as well, since I'm right here. Let's go ahead and clean all these jacks on the back here. Might as well while we're at it. Okay, let's fire this thing back up. Well, I can kind of already tell it's still doing it. Still got the problem, I think, with the reverb. Yeah, it's on there. No, it's a connection right there. It's one of those connections right there, and I think I might be able to get it from the top of the board, thank God. I think it's that middle connection right there. Okay, because it's working right there. There's no reverb, reverb. No reverb, reverb, and all I'm doing is barely, and I mean barely, moving this center wire. Okay, first things first, I'm going to solder these connections over here on this end. Yeah, there is a screw that holds this in, and thank God I could just unscrew this and the whole connector will come out the top. So, okay, I think I see it. I think I see the problem. Yeah, do you see the problem? The problem is right there. That connection is broken. So we'll reflow all this solder, but that's the one that's definitely, I'm sure, causing an issue. One of these might be broken as well. Of course, this is a a high stress area. It is an input jack, so it's likely to happen there anyway. But at the same time, I think the solder that they've used is not the best stuff. So I'm going to also look around on this board before we zip everything back up and make sure there aren't any more problem areas. Kind of hard to see around the camera, but I'll get it. If they had simply had a terminal, you know, like a terminal strip here instead of this board, you know, they could have, it's because it's just jumpered. It seems pretty silly to have, you know, there's 1, 2, 3 possible points of failure, but we also add 3 more possible points of failure. Why not just have these wires tied directly here? And it would just cut out 3 points of possible failure. It just, I don't know. Those are the sorts of things that you kind of trade off when you go to a modern amplifier. Okay, so I'm pretty sure we've solved the reverb problem. We're going to look for some more problem areas, and usual suspects are where jacks mount to the boards for one. So we'll a big high traffic jack is the foot switch jack always. So we'll check the connections on the foot switch jack, and those look pretty good to me. I don't see a problem there. Another high traffic jack is of course the input jacks. Those are always suspect for possible issues, and I don't see any issues really there. Pots as well. We're just going to move right down the line here, check all the pots and everything on the front board. Although there are no current problems with any of this stuff, we want to make sure that none arise in the near future. Okay, the only one I see that's even halfway suspect is that one right there. You can see that kind of that black ring around it right there. It might be a broken solder joint right there, or it might be a stressed one at the very least. And I don't see anything else that jumps out at me. Hopefully that'll take care of that, and then we'll go through also and we'll clean the sockets and clean the jacks and everything, and I think that's going to take care of it. The other complaint was that every now and then you would get a bit of a noise, you know, like something was loose or like there was a dirty jack or something. But that also could have been the speaker jack, because it was, I could just touch the speaker jack and the amp would make noise. So I think it might have been that speaker jack. But I think we're pretty much, I mean, this is going to be a fairly easy one. It's just, you know, mainly on this one it's interesting because it's, first of all, it's a rare amp. They didn't make a whole lot of them. And I mean, look at this. It's just, this is no fun whatsoever to try to troubleshoot. I mean, if I had real problems with this thing and had to pull these boards, this could be a nightmare real quick with the way that this is in here, because you'd have to pull the board and put it back down to test anything, and you've got all these connectors, these spade connectors that are mounted directly on the board here, and it's just, man, you know, not fun at all. Okay, luckily we were not going to have to do any more troubleshooting on this amp, but it still might be instructive to take a look at the schematic, especially since we've never seen this model before on the channel. If we look down here at the information on the schematic, this thing is dated 2/14 of 1994, so it's February 1994. This is giving me a very stern warning that this is all proprietary information and that I should not share it with anyone, so sue me. Anyway, let's see. Pretty standard power supply down here. You can pretty much ignore this because this is the export transformer wiring, so we can ignore this bit here. Got your power coming in. Here's your power transformer. Here's the filament winding. Here's the main winding. All this is fairly standard for a power supply in tube amps, that is. We do have an additional power supply down here that's going to supply us with our bias voltage, and also we're going to get our 27 or so volts supply that we're going to need for our switching. This over here is the switching, and it's done using some ICs and also some relays. You can see some relays here, and they have associated relays in different parts of the schematic up here as well. There's 3 here, there's 1 here, and there's another one down here before the phase inverter. And these do different things throughout the circuit. These 3 here are these 2 actually are the main ones that control the channel switching. So basically, this is pretty standard for a Fender tube amp, or the stuff that we're used to seeing on this channel. We have a couple of inputs here. We have 68K grid resistors. We have a 1 meg ground reference grid leak resistor here. We go through this first stage and we go through a 0.01 microfarad capacitor, and here's where things kind of diverge. The signal takes 2 different paths. It goes on into this stage here and then on through a tone stack, and this is basically your main channel, your first channel. You have a little pull cut here, and you can see what the pull cut is sort of doing. It does 2 different things at once. There's a switch here that completes the circuit over straight over to the grid off of this 100 picofarad capacitor, so it completes basically a bright cap, puts that in circuit, and also it looks like it takes this 22 microfarad capacitor on bypass out of the circuit, but it also, you can see it splits off and comes down here and goes into this relay. So when this relay is activated and this connection here is connected, you can see there's 2 different possibilities. Either it's going to be here or it's going to be connected here to ground. When it is connected here, that means the signal can go through this capacitor here and onto one of these 2, and it depends on what is selected down here. So if this one is selected, you're going to get your signal coming through this pot. If the other one is selected, it's going to go through this pot down here. So you got 2 different types of gain. But after that, the signal comes through over here, and instead of just one stage and into a tone stack, if it stayed up here on the first channel, when this is selected down here, you have you have 1 stage and a tone stack, and then you have another stage before it gets mixed back in right after the tone stack up here on this this section. So yeah, this relay right here is also kind of doing traffic duty as to which signal is going to get through to the next stage. So that I mean, this is fairly standard for most of the tube amps that we see, but the main difference between earlier Fenders and this one is all of this switching circuit stuff down here. And there's definitely a learning curve associated with this stuff if you're not used to messing with it. And I don't see a whole lot of it because most of the stuff I deal with is vintage stuff. I do see some of it, but it's kind of few and far between. But if we did have a problem down here in the foot switch operation, if we suspected there was a problem in this area, what we could do over here is come over here to these test points, and basically it has all of these here listed for you: TP 35, 36, 37, 38. So what you do is come in here with your meter, and anywhere where you see this like TP 35, you would stick your meter here and also to ground, and you would check and see that you would have about 9.04 volts of voltage at this point, and then you come through and check TP 36, and these should also be labeled on the board. I did not check that, but those TP test points should also be labeled on the board. Usually they are, but this will tell you what to look for if you suspect there's a problem in the switching. So that's helpful. But yeah, you know, this is, I mean, other than the switching stuff, I mean, this is a fairly straightforward amplifier. You know, one of the things I did not like, of course, is the fact that it's just so crowded in there, and you have the PCBs kind of upside down. You know, it is, in some way, it's better to have your solder side upward, because you can test components and everything a little easier when it's like that. But still, it just makes it a little more difficult to see what is what inside the amp, and you know, at first glance, it's just a bit more intimidating, I guess. You know, than it's definitely not the same as opening up an old Fender and looking at something like that. Would be much easier, much quicker to fix, I think, an old Fender than it would something like this. But at any rate, cool sounding amp, I have to admit. This thing does sound pretty great. They also have a service diagram, a layout diagram here, if you're interested in that. You can also find this online once again. This is good for, again, both the 93 Super and Concert amplifiers. But yeah, this is one of the things I definitely don't like about it. All of the tubes are direct mounted to this board, and I'm definitely not a big fan of direct mounting tubes to PCBs. It does make the process of building these cheaper. It does make it where they can cram in more features in a smaller space. So I get it. You know, I know why it's done. You know, it's a lot less labor intensive. There are a lot of reasons to do PCB, and I get that. But the flip side to that is much more difficult to work on. You're going to have a lot more problems as you know, as the years wear on with something like this. That are going to be increasingly susceptible to irreparable problems. That is, you know, if something burns on this board, you may destroy the board and have to replace the entire board. And if you can't find a replacement board, then you'll be pretty much screwed. But you know, it is what it is. They were made to be cheaper, made to be quicker. But anyway, here's the layout. So all right, let's give this thing a listen. Okay, so that'll do it for this 1993 Super/Concert amplifier type PR244. I hope you guys enjoyed this video. If you have, please hit subscribe down below. And for now, we'll see y'all later.